Hey there, y'all. Today we're going to look at 1.4 on rational exponents. In this section, our objective is to be able to simplify exponential expressions with rational exponents using the properties of exponents and radicals. We're still under the same standard of being able to express exponential functions by using their properties of exponents. And so first off, there's two key skills we need to talk about that are important to solving and working with rational exponents. The first is we need to be able to work with fractions. We need to be able to add fractions, subtract fractions, and multiply fractions. And we also need to be able to use the properties of exponents that we talked about in 1.3 and also the properties of radicals that we talked about in 1.1 and 1.2. And so let's look at a few examples here of how we work with rational exponents. And that word rational, again, remember that word rational means that we are talking about fractional, right? Because remember the word ratio is a number that's written as a fraction, right? And so fractional exponents. And so looking at example 1a, we want to be able to evaluate these expressions and write them with only positive exponents. And so we have 2 to the 1/2 times 2 to the 1/2. And so remember that's our product rule, and so the base will stay the same at 2. And then our powers are going to add. So 1/2 plus 1/2 is 2 halves, or 1 whole. And so we get 2 to the first, or just 2. And we can do that with any power, right? We could do it with 1/2 plus 3 halves. We would get 4 over 2 and reduce down to 2. And so we can do it with any fractions. As we look at example B, we've got x to the 4/5 times x to the 9/2. Now, these two fractions aren't going to add together as easy. And so we might want to come out to the side here and do 4/5 plus 9/2. And remember, to add fractions, we need to have a common denominator. And so, your middle school teachers might have taught you a couple different methods, but remember the key to adding fractions is to have a common denominator. And so what would that common denominator be for 5 and 2? Well, if we multiply 5 times 2, we get 10. And so multiplying the denominators will always give us a common denominator, but it won't always be the least common denominator. Remember, the least common denominator would be the first number that both numbers could multiply to. And so for 5 and 2, that is 10. But what if we had 6 and 4? Well, 6 times 4 is 24, so we could use that as our denominator. But we could also reduce that down. 6 and 4 also multiply to 12. And so that would be the least common denominator of those two numbers. All right, so coming back to this 4/5 plus 9/2. Well, remember that when we multiply this 5 to get 10, we multiplied it by 2. But whatever we do to the denominator of a fraction, we also have to do to the numerator. And so the 4 is going to get multiplied by 2 and give us 8. And then we look at the second fraction, 9/2. Well, we multiply the 2 by 5 to get us 10. So we're going to multiply the 9 by 5 to give us 45. And then we're able to add those two fractions together. And remember, to add fractions, we're going to add the numerators and keep our common denominator. So our denominator is 10. 8 plus 45 is 53. And so this is going to be x, because we keep our base with this property, to the 53 over 10 power. Now again, that seems like a crazy power, but the property is what it is, right? We're going to add these fractions and get our new rational exponent. Okay? Let's look at example C. We have 7 to the 5th to the 3/5 power. And so since we are power to power, remember, we're going to multiply those two powers. And again, we might want to come off to the side and do it as scratch work. So 5 times 3/5. Well, remember, to multiply fractions, we multiply straight across, numerators to numerators, denominator to denominator. And so we can put this 5 over 1. So we're going to get 5 times 3, 15. 1 times 5, 5. And so 15 over 5 reduces to what? 3. And so this is going to give us 7 to the 3rd power. And again, for what we're working on here, we can leave it 7 to the third. If we actually need the value, we can rewrite it, and 7 to the third is 343. Let's look at example 2, where we're talking about converting from rational exponents to radicals. And so remember, this goes back to section 1, relating rational exponents to radicals. And so if I have a to the m over n power, we can convert that to a radical. The a will be our radicand, the part inside the radical. And then our index is the denominator of that exponent. And so, again, the denominator is the index. And the numerator, the m in this case, will be the power outside. And we'll put that around in parentheses. Now, you might also see it written with the power inside. So the nth root of a with the power inside. So the nth root of a to the m. That is another way to write it. But for what we're going to be doing with these type problems, we're going to want to have that power on the outside. Because we're going to want to simplify the radical part first, which will give us a smaller number typically, and then raise it to the power that is requested. And so let's look at example A. 4 to the 3/2 power. Well, we're going to rewrite this as a radical. And so put your radical, and the 4 will go inside. The denominator of this power will be the index, so we're doing the square root. And then the numerator of this power will be the power. And so we're going to reduce this part inside first. What is the square root of 4? Well, what times itself gives you 4, right? So the square root of 4 is 2. And so 2 cubed, well, 2 times 2 is 4, times another 2 is 8. And so the final answer here is just 8. Okay? Let's look at example B. 8 to the 2/3 power. So again, we're going to convert this over to a radical so we can simplify it by piece. And so we're going to write our radical. The 8 will be the number inside, the radicand. The 3 in this case is the index. And the 2 is our power out back. And so we're going to ask ourselves, what is the cube root of 8? Well, what times itself will give us 8. 2 times 2 times 2 is 8. And so we're going to get 2 squared. And 2 squared is what? 4. And so we see that there. Okay? And so again, we want to take these three pieces, the three components of this rational exponent, the base, the numerator, and denominator of the power, and put them each in their own place as a radical and be able to simplify it. Let's look at example C. We have 32 to the 8/5 power. So a little bit larger number here with larger power and denominator. And so, again, we'll put our radical. The 32 will go inside. The 5 is the index. And the 8 is our power. And so we have to ask ourselves, what times itself, times itself, times itself, times itself gives us 32. Well, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So this is going to be 2 to the 8th. And so now I got to do all those 2's multiplied together. Well, we just talked about 5 of those together was 32, so we just keep going. 6 is going to be 64. 7 is 128. And 8 is 256. And so 2 to the 8th is 256. So we can get that value there. Okay? So again, we're going to use those powers to simplify this to its own value. And let's look at D. We got one more example here, and we'll erase that part. 49 to the negative 3/2 power. So 49 to the negative 3/2, well, in this case, we've got to deal with that negative exponent first. And so dealing with the negative exponent, all of this is going to go to the denominator and change that power from negative to positive. And so we're going to get 1 over 49 to the 3/2 power. Okay? And so now we'll deal with that rational exponent and make it a radical. And so we'll rewrite it 1 over the square root, because that's our index, of 49 to the 3rd power. And so again, we'll break this down piece by piece. The square root of 49, what times itself gives us 49? Well, that's 7. And so we're going to get 1 over 7 cubed. And 7 cubed is 343, so the final answer here is 1 over 343. So we see how with that negative exponent, we still have to deal with it before we can change it from that rational exponent into the radical. Okay? Now, the big key here with all these problems is I want you to be able to convert it from rational to radical. Because, yeah, you could do this on your calculator, right? We could type in 49 to the negative 3/2, and it would give us the decimal of what 1 over 343 would be. But being able to convert from one to the other is important for solving equations. And that's what we're getting to as we get further through this unit and into other units. We need to be able to use these power rules to simplify equations. And so that's where this skill is important. Let's go ahead and look at example 3. And we got a couple examples here of converting the other direction. We're going to convert from radicals to rational exponent. And so these, we're not going to want the decimal, right? Because like the 5th root of 4 to the 8th, it's going to be an ugly decimal because the 5th root of 4 is 1 point something really small, right? Because if I'm taking the 5th root of 32 is 2, so we're something like 1.1. So we're just converting these to be able to convert from one to the other. Again, it's just practicing that skill. And so we want to convert this over. So remember what goes where. Well, the 4 becomes the base of the exponent. And then we're going to have our power, which is a fraction. And remember that the index is our denominator. And the power is our numerator. And so we end up with 4 to the 8/5 power. And again, we're not looking for the decimal here. We're not looking to simplify this. We just want to convert it from the radical form into the rational exponent form. Okay? And so there's one more example we're going to look at real quick. The 7th root of 12 to the 4th power. And so again, we're converting this over. So 12 is our base. Think about what goes where for our fractional exponent. The 7 is our index, so that'll be our denominator. The 4 is our power, and so that would be our numerator of the final power. And so this is 12 to the 4/7 power. So again, a lot of the skill that we're working on here is being able to simplify and be able to convert from one form to another, because this is a skill that we're going to need later on as we look at things in intermediate, but also in geometry when we deal with radicals for different functions of different types of shapes. And then as we get into higher math, dealing with certain types of functions that we'll learn about in Algebra 2. And if you go on to pre-calculus or calculus, you'll see those there as well. So that's the end of this lesson. If you've got any questions, make sure you ask. And I'll catch y'all on the next video. Y'all have a good one.